So who else was super excited about the radish news? Just me? Okay. At the end of 2020, the very first radish was grown and eaten in space, and it's a big deal, and I'm gonna tell you about it. Actually, no. Let me do you one better. I'm gonna get an actual NASA scientist to tell you about it. Today I've got NASA's own Dr. Gioia Massa talking to us about the farming programs on the International Space Station, so let's get into it. I'm Sarah Gilbreath, and this is the Martian Street Food Society. Okay, background information. There are two different NASA programs for space farming, V.E.G.G.I.E and the Advanced Plant Habitat. To help me understand them more, I was lucky enough to be able to talk to NASA's own Dr. Gioia Massa.
My name is Gioia Massa, and I'm a life sciences project scientist at NASA's Kennedy Space Center. I work both in our area of space crop production, helping to do research in this area. I also work with external investigators who are going to be flying their experiments on the space station and to help them get their research to be successful in space. And then I do a lot with education and outreach as well. I actually became really interested in growing plants for space when I was 12 years old. And I had an agriculture teacher who was invited to Kennedy Space Center to learn about the research that was going on. This was quite a while ago. And he brought back tons and tons of information and video, and I just watched it all, and I was completely captivated. So I decided then that this was really what I wanted to do with my career.
The news that came out from December and January about the radishes, that was a big deal. What can you tell us about that experiment or the V.E.G.G.I.E-03 experiments that have happened since then?
So V.E.G.G.I.E was launched in 2014, and we actually started eating produce from V.E.G.G.I.E in 2015. But the radishes were not grown in V.E.G.G.I.E. They were grown in our advanced plant habitat, which was launched around 2017. And this is the first crop that we've grown in the advanced plant habitat, we call that APH, that we've actually had astronauts eat. Advanced plant habitat, unlike V.E.G.G.I.E, is a much more automated controlled system. It's really a plant physiology research chamber. So we can control almost every aspect of the environment. V.E.G.G.I.E is more simple. It's more of an astronaut garden where most of the environment's actually controlled by the external space station environment.
So why were the radishes important? Well, first of all, they're a different kind of crop than what the ISS has had success with before. Many of the more successful crops have been leafy greens or even dwarf wheat, but radishes represent an entirely different group of plant.
The radish experiment was conducted in the APH over fall and winter, two sets of radish growouts. This was an investigation by an external principal investigator, Dr. Carl Hassenstein at the University of Louisiana Lafayette. The astronauts wanted to grow some additional crops, and so Mike Hopkins and Kate Rubin are both very, avid gardeners. So they started growing the crops that we'd had stored up there to grow in V.E.G.G.I.E. So J, K, and L were sent more recently. J was fascinating though, because it was testing a new technology called a seed film, where we have this water-soluble, food-safe polymer that we were able to embed the seeds in. And the plant pillows, instead of us planting them here on Earth, the astronauts actually got to plant them with the seed film on the space station. So this is kind of testing, can we plant on orbit in this way, and will the seeds stay, stored in these films and germinate really well? And that one was very, very successful. And then we've since grown two additional crops, V.E.G.G.I.E-03K and L, and those are what are growing right now on space station. One is Amara mustard. It's a very meaty flavor. We actually call it the steak plant. And the other is extra dwarf pak choy, which is like a little baby bok choy. And this was a crop that was selected from testing that we have with a student citizen science program. So middle school students and high school students helped to select this crop through a program called Growing Beyond Earth. So we actually had, a lot of success with these 5 experiments. We're really kind of riding a wave of excellent news right now on plants and space.
Before any of the crops can actually make it up into space, they have to go through a number of pre-flight verification tests here on the ground. Those tests are looking for any number of factors that might inhibit the plant's growth on the space station. They're also checking for something called organoleptic appeal or organoleptic acceptability, which really just means whether it looks and smells and tastes good. I'm gonna start using that in my daily life, like when I go to restaurants again. What can you tell us about ground control? Like who designs the experiment, or how much control do the people on the ground really have of these experiments?
Well, we have our space crop production group at Kennedy Space Center, and this is where we're doing, a large variety of testing, including testing new crops and trying to identify which crops will be good candidates for space. So we have kind of a rolling suite of that testing, and we actually work with the middle schools and high schools who are helping test in their classrooms as well. So they're identifying good candidate crops, then we test them under our higher fidelity conditions. And we try to mimic the ISS environment. We actually grow crops and send them to Johnson Space Center, where they have the food lab, and they do taste tests there. So we get data on, which crops actually have organoleptic appeal. I had a team that had experiments looking at different red to blue light ratios and how that impacted crop growth, nutrient content, organoleptic acceptability, and microbial food safety, and even behavioral health. And then when crops are growing on space station, we provide support to the astronauts. And that support really varies dependent on kind of what the crew wants. In the last few years, we've worked towards this autonomous approach because, when we have astronauts on Mars, we're not going to be telling them how much to water their plants. And so we want them to be able to use the tools that we developed to make those decisions.
Now, if you've seen the episode I did earlier with Audrey Glasgow from the US Space and Rocket Center, you might remember her story about the astronauts baking chocolate chip cookies in space. Those astronauts weren't allowed to eat those cookies. They had to send them back down to the ground to be tested. That's true of the vegetables grown in these space farming programs as well, at least to start with. You had just mentioned that you had to do some tests to make sure that it was safe for humans to eat before they actually consumed it. What kind of testing is that? And is it done on the space station, or does that have to be sent back down to the ground for testing, like at ground control?
Well, for the very first set of lettuce that was grown in V.E.G.G.I.E, the astronauts weren't allowed to eat that one. So that was V.E.G.G.I.E, the very first set. And this was the red romaine lettuce, which is the same crop that we've grown multiple times and was actually the crop that was used in those seed films. We didn't know what microorganisms might be coming in from the space station environment and if it would be safe to eat. So for that test, we actually had the astronauts grow it, harvest it, freeze it, and send it back to Earth without any consumption, or at least without any that we were aware of. We look for like total number of bacteria and fungi that grow on the leaves, as well as look for specific pathogens, things like salmonella. But we also have produce sanitizing wipes that are part of our veggie science kit. We came up with a plan that even though the produce should be safe with the levels that we identified, we would still have the astronauts do kind of a cleansing step, just to make sure, which involved putting layers of leaves in between the layers of wipes and then kind of pressing them all together like a sandwich. But we still take samples back, so they don't eat the whole crop. They eat, say, half the crop, and we bring samples back to just confirm that their microbiology is good.
So ground control is choosing the crops, and they're making all the plans, and they're giving guidelines for how all of these things should be farmed. But it's the astronauts who are the ones who are actually doing the gardening day to day. These are not remotely controlled systems, and unlike some of the other systems we've talked about previously, astronauts are allowed to stray from the directions given to them by ground control if they think it's in the best interest of the crops.
Scott Kelly actually helped to pioneer this. He was growing the zinnias, which were the third crop grown in V.E.G.G.I.E, and we had some problems with that crop. We actually had a lot of problems. What happened was the fans were shut off, and we didn't know. This is sort of a hardware fluke that when power is taken away and then restored, the indicators that the fans are on come back on, but the fans themselves don't come back on. And when this happened, water was building up in the chamber. But he said, I'm the one who's here. I should be able to decide, how much to water and when. And we said, yeah, that's exactly what we want. And he was able to restore the fans and basically control and water the experiment very precisely, and he got flowers to bloom. And so it ended up going from kind of a failure to a huge success, but it also pioneered this on-orbit gardening.
Now, this kind of space farming may not seem that important now. After all, we have been shooting people up into space for decades, and obviously their diet has worked out just fine for them. But those people have been up there for relatively short stays. Anybody going to Mars is going to be there for a much longer length of time. And that means they're going to have different dietary needs that currently we can't meet.
The packaged diet is great. It's very diverse. There's about 180 different foods and another 20 or so beverages and condiments. But if you're storing that diet over time, the quality of the food degrades and the nutrient quantity of the food degrades. So the vitamins especially break down. And that means that right now we don't have a diet that will sustain people on Mars, because we may need to send some of that food ahead of time. It might be sitting on the surface before the astronauts even launch from Earth, right? And so as that food ages, we can't guarantee that we're going to meet all of the nutrient needs. So fresh produce can supplement that diet and provide those nutrients.
One of the things that we really take for granted here on Earth is air convection, which just means air moving around based on whether it's warmer or colder. Warmer air is less dense and tends to rise, whereas cooler air is more dense and is pulled down. And yes, if you have a convection oven, this is exactly what happens inside your oven to keep the air moving around and circulating. Now, if you're in an area that doesn't have gravity, like up on the space station, that kind of air movement doesn't happen. That's really problematic both for the astronauts and for the plants.
So when you have a lack of convection, heat doesn't rise, air doesn't move, and fluids behave really strangely. So air and water don't mix well. And, you'll see the bubbles of water floating around that the astronauts, inject from their drink bags. And if they put an air bubble or two in there, all the air bubbles will coalesce into the center. So you'll get a bubble of air inside a shell of water. And that's really fascinating and fun to play with, but it makes it really hard to water your plants. Dissolved oxygen doesn't stay in solution in microgravity. So watering our plants has been the biggest challenge that we've dealt with.
As always with new sciences and new technologies, sometimes things go wrong. There are a number of pretty significant issues that have happened on the space station that farmers on Earth have never had to deal with before.
When the fans are off, you are not moving that water. Everything's limited by the rate of diffusion, which is really slow. And so you have to have fans. And it's the same for the astronauts. You have to have fans, or if you were to take a nap on space station, you'd get a big bubble of CO2 forming around your head if you didn't have fans actively blowing that away, because there's just no natural circulation. And I think people just kind of forget what that means, but it basically means you might not wake up from that nap on space station if you don't have those fans.
And if you think that the current list of crops available on the space station sounds a little bit bland, don't worry, they are about to spice it up with some new crops, including peppers.
We'll be growing dwarf peppers, kind of a chili pepper, an Espanola improved chili pepper in the advanced plant habitat. First test of a fruiting crop in this hardware that the astronauts will get to eat and have something spicy to add to their diet. And then we're going to be growing dwarf tomatoes in V.E.G.G.I.E early next year or mid next year.
NASA's also got a bunch of really cool new experiments coming up down the line, including some stuff on the moon.
In the future, we're going to be growing plants on the moon, and we're going to be testing out the technologies that we need to get to Mars on the lunar surface. We're also going to be testing things on the space station or on the Gateway that'll be preparing us for the transit mission to Mars, which will be more of a deep space transit, where we're going to have these higher levels of radiation, but no gravity. So the future is really exciting and bright in terms of space crop production.
My question for all of you guys is, what kind of food would you most like to see grown in space? Thank you so much for watching. See you next time.